In this chapter 25, we will study the electrical potential. The electrical potential. Okay. So far, we have studied the Coulomb's law. Okay, and we have that if we have 2-point charge Q1 and Q2 like this, with the distance R, with the separation of the distance R. Okay, we have that F E. This is the magnitude of the electric force, which is equal to K Q1 Q2 over R squared. Okay. Now, if we compare this with the situation that may seem totally different. For example, if we have the mass M1 and M2 with the separation R, we know that these two masses will exert the gravitational force with each other, and the expression for the gravitational force is Fg is equal to G M1 M2 over R squared. Okay, so this means that if you compare the mathematical expression of the electrical force this one, and the gravitational force, this one, you can see that they have the identical form. If we ignore the meaning of the variable like K, Q, or G, M, just look at the mathematical form. They are identical, and from this similarity, or from the fact that these two expressions are mathematically identical, some property of the gravitational force, if we know that there are some property of the gravitational force, it is possible that the electric force will have the same property too. And one important property of the gravitational force the gravitational force is a conservative force. Gravitational force is a conservative force. To be a conservative force, it means that we can define the gravitational potential energy. gravitational potential energy. Okay. Now, when we look back to our electric field, electric force, since the mathematical property of this force must identical with that of the gravitational force, we can conclude that the electric force is a conservative force too, which means that we can define the electric or electrical potential energy. The electrical potential energy. Okay. And the process of defining the electrical potential energy is similar to that of the gravitational force or any force, any conservative force, any force that we know is conservative. Okay. From that, recall what we have learned in physics 1. We have that the potential energy is equal to the minus of the work done by the force. It means that if we want to calculate, we have the difference of the potential energy or the potential energy difference is equal to the minus of the work done by the force. So it means that if we want to calculate the potential energy, the electric potential energy difference, it must equal to the work done by the electric force. Okay, work done by the electric force. To look in more detail on this process, let's see. Okay, if we have a test charge placed in a region with an electric field, okay, and if this test charge moves from point A to point B, okay, the electric force on this test charge is equal to Q0E. Okay, so if we want to calculate the work done by the electric force, is equal to the integral from A to B of Fe, which is QE dot dr, where dr is the displacement vector along is dr. Okay, this is the definition of the work done by the electric force when the test charge moves from point A to point B. Now, from the definition of the electric potential energy, it means that the potential energy between point A and B UB minus UA is equal to the minus of the integration from A to B of Q0 E dot dr. So this is the expression of the electric potential energy difference between two points A and B when we place the test charge Q0 in this region. Okay. The unit of the potential difference is the unit of the work, right? From this equation, which have to be the unit of the energy. It's the unit of the energy. So we must have that in SI unit, the unit of electrical potential energy is joule. Like this, which is the unit of the energy. You can see that from this definition, which is the common property of the potential energy, that is, in general, we cannot calculate the absolute value of the potential energy. What we can do is the difference of the potential energy between 2 points, but we cannot calculate the absolute value of the potential energy unless if we define a reference point. For example, if we define that A is a reference point, so we can calculate the potential energy at point B relative to A. That is the absolute value, but in the sense that this is the this value relative to the reference value at A, and sometimes in some situation we can set the potential energy at the reference value equal to 0, but that is not general. Sometimes we cannot, but most of the time we can choose some reference point and set the potential energy equal to 0 at that point. Okay, so this is a general picture of the electric potential energy. Next, we will define a different quantity which is called the electric or electrical potential. The electrical potential and electrical potential energy are different. Okay, but this difference is very similar to the electric force and electric field. Okay, and the concept of electric or electrical potential is very useful. Like the concept of electric field is very useful